So good evening. I'm gonna try to explain to you what I was explaining to you in class today because I know this topic is not easy, right? I mean to find the inverse and do the solving system of equations using the inverse. It's not an easy process. What I suggest you to do is I heard someone in the class said today, "Oh, I wish I could do it." There's no such a thing as I wish I could do it. You can do it. Think about it. How much time you spend sometimes on social media or doing other things that they're not important or they're not beneficial to your life. So my advice to you is like, or the advice that I always think about is the more challenging it is, the better it is. It is for me. Like many times, many times, this is what people don't tell you. Even like most mathematicians, they don't tell you this. They fail test. They do fail test. They just keep quiet. They don't tell you, but they do fail test. I failed many tests in my life. So I'm telling you, it's not wrong to fail. What's wrong is like when you just want to get a grade and you don't want to learn. That's the problem. The reward, the grade, it's yeah, it's nice to have an A, but it's more nice when you apply to a job and you know what you're doing. And like all the other people that they have A and they have no idea what's going on, they look bad after that. So that's my advice to you. If you want to do something, learn it from the heart. Don't learn it just because you want a grade. If you need my help, I want to help. I can help you, but you need to practice. Okay, so let's. We need to find the inverse here, right? So let me. I have answer this time, just in case to avoid mistake. Let's copy this. Let's see here. Okay. So first, in order to solve the system of equations using the inverse, we need to first need to compute the inverse, right? And before you compute the inverse, you should be able to say, oh, is this matrix invertible? It means, is this matrix has an inverse? Sometimes the matrix, they don't have an inverse, right? So the first thing you have to check is if the determinant is equal to 0, then that means there's no inverse. I think I explained that in class today. If the determinant is equal to 0, there's no inverse. And you always want to look if you have the same number of rows, or if you have two rows that are exactly the same, or if you have two columns that are exactly the same. So you can do that, right? That's why you're supposed to look at it. Don't just compute. Try to think about this problem, right? Okay, so let's calculate the determinant here. Let me copy this one more time. Okay. So if we want to find the determinant, we can do many ways, right? So I see zeros here. I can do that way if it work it out for me. So we can do that if you want. Let's see. Let's see. Well, let's practice with the Sarus first, just to review. Sarus method. The Sarus method is the diagonal method. So this is -3, 0, 3, 6, 0, -5. Okay, so let's do that as a practice. This with this, this with this, and this with this, right? So we multiply those numbers together. So there's a 0 here, so that's 0. There's a 9 and 6, that's -54. And then there's a 0, right? So this is 0 minus. Now you have to do this way, right? So this way, and this way, right? So you have 3 times 0 times -3, that's 0. 83 times -3, so you have three negatives, so that's going to be a negative, right? Negative and negative makes a positive, positive and negative makes a negative. So you see three negatives, that means that's a negative. So 9 times 5 is 45. And then 6 times 0 is just 0, right? So that doesn't matter if I put plus 0 or not, right? -54 plus 45, right? So this is -9. So there's a determinant. It's not 0. So that means that this matrix has an inverse. You can call this matrix A if you want, okay? Just call that matrix A. So matrix A, the determinant of matrix A equals -9, right? now that we compute this, and now that we know that this matrix has an inverse, we need to compute the inverse, right? So the process of computing the inverse is not that easy, right? Because it's tedious. So let's do that, the tedious part. Okay, let's do the inverse. So I should not copy this. Let me see if I can cut this. Okay. So let me just copy that. So we need to remember the goal is what? The goal is you have this matrix A, right? And if you want to find the inverse, you need to do this is basically what you have. You have a matrix A, and you need to, and you on the other side, once you augment the matrix, you will have the identity on the right side and the matrix on the left side. Your goal is what? To have the identity on the left side and the inverse on the right side, right? So that's what we have so far. This is what we have right now, right? So I mean, not really, but I mean almost like that. So this is -3, 0, 3, 6, 0, -5. And this is -3, -3, and -5. And I need to augment it, right? So this is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So you need to get the identity on the left side. When I'm talking about the left side, I'm talking about here, right? You need to get the identity here. If you can do that, then that means you found the inverse. So let's do that. So we have to do the row operations, right? We need to do the Gaussian elimination or whatever you want to call it. So now we can remember, the goal is always doing this, right? When we're doing Gaussian elimination, we want to get this, the identity, right? And usually I always tell you, right? The first thing you want to get rid of is those zeros below the first pivot, these two guys. You always want to get rid of those two first. So let's do that. So I need to multiply 2 row 1 plus row 2, and that will give me new row 2. The only difference that when we're doing this than the Gaussian elimination is that we have to do it now 3 more times for one row, right? Because before we just have, yeah, we have to do it 2 more times. Before we just do like 3 numbers or 4 numbers. Now we have to do 6 numbers. That's the only part that is annoying, right? So let's do that. Let me make this smaller. Okay. So this stays the same. I should not copy this. Okay, sorry about that. Okay. So I'm gonna erase row 2 because I don't need that, and because I'm gonna get a new row 2. So 2 times -3 is -6, plus 6 is 0. 2 times 0 is 0, plus 0 is 0. 2 times 3 is 6, and 5 is 1. 2 times 1 is 2, and 0 is 2. 2 times 0 is 0, and 1 is 1. 2 times 0 is 0, and 0 is 0. So at this point, you can see what's happening already, right? I have the row zeros that I want or that I was expecting, right? And what should I do now? I can do a row exchange, or I can get rid of the -3 in the row 3, right? The first element in row 3. At this point, it's just optional, right? For simplicity, to make it more visual, I'm just gonna exchange the rows. So I'm gonna exchange row 2 with row 3. So row 2 exchange with row 3 gives you a new row 3. Okay, so this is this thing. So we exchanging row 2 with row 3. So let me change that. So we have now 0, 0, 1, 2, 1, 0, and then we have -3, -3, -5, and 2, 1, and 0. Actually 0, 0, 1. My bad. 0, 0, 1. Now we can get rid of row 2, right? To get a new row 2. So we can just do 1 row 1 plus row 2 give me new row 2, right? I can do that. So that means I can do this thing, right? That means I can erase row 2. So let's erase row 2 and let's do the computation, right? So this is negative 1 times negative 3, that's just 3, and negative 3 gives you 0. Negative 1 times 0 is 0, and this is negative 3, and negative 1 times negative 3 is just negative 3, and negative 5 is negative 8. And negative 1 times 1 is negative 1, and 0 gives you negative 1. Negative 1 times 0 is 0, and 0 is 0, right? Negative 1 times 0 is 0, and 1 is just 1. So now what you can do is you have that situation that we want from the beginning, right? We want the zeros here, and we're supposed to expect 0. I mean, we're supposed to eliminate the 0 here, but we got lucky because we got a 0 there, so we don't need to compute that. So at this point, like I said before, when you have this situation in the matrix, right? Now you have a row echelon form. What you want to do is get reduced row echelon form. So in order for you to get reduced row echelon form, right? Right now, just in case for the vocabulary, this is row echelon form, right? And you want to, that implies that from here you want to go to reduce row, right? Reduce row echelon form. Reduce row echelon form is what you have here. It's the identity matrix, right? So what you need to do next is you want to get rid of those elements above the diagonal. So I'm talking about these elements right here. So these three. Once you get rid of those 3 elements in this matrix, then you will have the inverse, right? So this is what we need to do. Okay, so next step is try to, like I said, we need to get rid of those numbers above the pivot, right? The pivot, the pivot in the last row. So in order to do that, we need to multiply by 8 and by 3. So 8 row 3 plus row 2 gives you new row 2. And let's do multi-step because I want to save some time. And then we can do negative 3, row 3 plus row 1 gives you new row 1. Right? So it's the same thing like before. So don't get confused with this thing. This is not a big deal. This is very easy. You have to think like that. Okay, what's next? We need to get rid of row 2, right? That we said we're gonna get rid of that. Okay, so that one is in green. So 8 times 0 is 0 plus 0 is 0. 8 times 0 is 0 minus 3 is negative 3. 8 times 1 is 8 minus 8 is 0. 8 times 2 is 16 and 1 is 15. 8 and 1 is 8 and 0 is 8. Let's double check. Yeah. Yeah. And 8 times 0 is 0 and 1 is 1, right? Now, you need to get rid of row 1, right? So we can do the computation for row 1. So let's erase this thing and let's compute. Negative 3 times 0 is 0, and negative 3 is negative 3. Negative 3 times 0 is 0, and 0 is 0. Negative 3 times negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 2 is negative 6, and 1 is negative 5. Negative 3 and 1 is negative 3, and 0 is negative 3. And negative 3 and 0 is 0 times plus 0 is 0, right? Okay, so that's what we have so far. Now, at this point, you can do many things, right? You can divide, you can multiply, you can do whatever you want. So at this point, I don't know why you got darker. At this point, you can divide by 1, row 2, right? Because anyway, you're gonna get some fraction here. So divide by negative 3. So negative 1/3 row 2 gives you new row 2. So let's do that. So -3, -1/3 times 0 is 0. -1/3 times -3, that's 1. -1/3 times 0 is 0. -1/3 times 15 is just -5. -1/3 times 8 is just -8/3. And -1/3 times 1 is -1/3. So what's next? You need to divide by -3, right? You need to divide by -3 row 1. So basically, you need to multiply by -1/3 once more. So let's put that in this time. -1/3 times row 1 give you new R1. Just compute this thing. This is not difficult. You can do it. Okay. If you get the wrong answer, do it again. Not a big deal, right? You can do it. So this is what? 1. And this is 0. This is 0. And then you have 5/3. And then you have 1. And then you have 0. So this number that I just got, remember, this is identity and this is inverse, right? And if we put it in those blocks, I call them blocks because that's what they are, block matrices. This is what I got right now, right? This is what I have right now. And before, I have this guy, right? I have that. And it went from this through this. And that was the whole point of doing this, right? Find the inverse. That's the way you find the inverse. The easy, I mean, one way to do it. There's another way to do it. I will explain to you next time. Okay. Now, so you need to write A inverse equals 5/3, 1, 0, -5, -8/3, -1/3, 2, 1, 0. So this is supposed to be your A inverse, right? If they have something different than you, that doesn't mean that you get it wrong. That means that they factor something out, okay? Maybe they factor 1/3 or some other number. Let's see what they have. I have no idea what they have. So they have some other matrix, right? That they have different numbers than I have, right? So let's see what they have. Now, if you think about it, if you, this number, it's a constant that they factor it out. Now, if you multiply this number to each element of the matrix, right? So I'm talking about this times that, this times this times that, you will get the same thing I have. Look, -1/9 times -15, right? So this is 15/9. But 15/9 you can reduce. That's 5/3, isn't it? Not the same? Yes? And then if you do the same thing for -1/9 times -9, that's just 1. It's not the same. And if you multiply -1/9 times 0, you can tell that that's 0, right? So that's A inverse. And you might say, Mr. Flores, but on the test I don't have that thing. How can I know if I got the right answer or not? Very simple. When we were doing today, remember I told you, right? Our goal is to solve AX equals B. A is a matrix. B is a vector. And this is all the vector of unknowns, right? X, Y, Z, or X1, X2, whatever they want to call it. And this is another vector. And when we're doing this, remember, I told you in order to solve for X vector or the variable of vectors, I need to multiply by A inverse in both sides. So A inverse times A gives you the identity times that vector X or the vector of unknowns, A inverse B. Identity times a vector is just a vector, A inverse B. Remember, when you're doing matrices, you cannot divide, I cannot say this thing. No, that's wrong. That's only that only work out for integers or real numbers, right? This is not a number, this is a matrix. So you cannot do that. Don't do that. That will be wrong. Okay? Don't do that. So if you want to get rid of A, you have to multiply by A inverse. And what was my whole point telling you this thing? So that means if I'm in a test, and if I have time, right? I most likely in a homework, not in a test, right? If I want to find out if I get the right answer, A times A inverse, which what I have should give me the identity. When I using the dot product. The dot product is when we're doing multiplying matrix row by column. That's called the dot product. Okay? So let me show you how to do that, and you can check your answer. So let's see, what was the matrix, or the original matrix was this guy. I'm sorry about that. This is the original matrix. So let's copy that and let's put it here. So this is my original matrix. This is what I have. This is A inverse. And my claim is A times A inverse should be equal the identity. And you know the identity is what? 1, 0, 0, 0, 0, 0, 1, 0, and 0, 0, 1. If you get that, then this is true, or what you compute is right. So you have to do the dot product. The dot product, remember, in order to multiply two matrices, they have to have the same dimension. So this is m times n, m times n, right? So this m, I told you in class, it's the rows, n is the columns. So we have 3 rows, 3 columns. Here we have 3 rows, 3 columns. In order for this matrix multiplication to work, n and n, they must have the same dimension. In this case, they do. Therefore, your solution will be this. You should get a 3 by 3 matrix. If these two, they're not equal, then you cannot multiply them. Okay? Okay. So let's do this that product. Okay. Let me do that here. Let me copy that one more time so you can keep these in your notes or in the video or whatever. Okay. So well, this one come on. Okay, let's copy this. Okay, so we have to do the dot product. Okay. So the dot product means this thing. I need to multiply row 1 by column 1, right? This is just to check. You don't have to do this. I'm just doing this because I want to show you. But in the answer key, you will have that, right? So you don't need to worry about that. Okay, so we have -3 times 5/3, and then we have plus 0 times -5, and then we have plus 3 times 2. That have to give it to 1. So this is -5, right? And then this is 0, because 0 times anything is 0, and this is plus 6. That's 1. Okay? Let me make this smaller because I need more room, right? Now, everything that I do now, it should give me 0 on the row 1 in my identity matrix sort of thing, right? So now I have to do row 1, column 2. I have to do the dot product. So this is -3 times 1 plus 0 times -8/3. And then I have 3 times 1. That have to give me 0. So this is -3, this is 0, plus 3. Indeed, is 0. So let's put that in different color. Okay, so this is green. Okay, and this is also green. Now I have to do the dot product again. Row, I can do row 1 and column 3. Again, these have to give me to 0. If it doesn't, then I did something wrong. Let's change the color. So that product, -3 times 0 plus 0 times -1/3 plus 3 times 0. You can tell that that's 0, right? 0, 0, 0. So that looks good so far. Now let's continue doing the computation. Now you're done with row 1. Now you have to do row 2 times column 1, right? So you do this times this. So let's compute. 6 times 5/3 plus 0 times -5 plus -5 times 2. You should get 0. So this is what? 10. This is 0. And this is -10. So you get 0. The main thing is not just computing. The main thing is understanding what's happening. If you don't understand, then that's when the problem arrives, right? Let's continue with the computation. Now we have to do what? Row 2, column 2, right? So we have to do the dot product. 6 times 1 plus 0 times -8/3 minus 5 times 1. 6, 0, -5, 1. And indeed, I'm supposed to get a 1 in there, right? Now you do one more time. Now you have to do row 2, column 3. So this is matrix multiplication. You're learning something new without even noticing. This is called matrix multiplication. And to be more specific, I'm doing the dot product. So 6 times 0 plus 0 times -1/3 minus 5 times 0, right? But this isn't really a plus 5. So 0, 0, and doesn't matter. It's 0. So 0. Next. Now I have to do the last row. Row 3, column 1. Let's compute this. So -3 times 5/3 plus -3 times -5 plus -5 times 2. This is what? -5 plus 15. And then this is -10. So this is -15 plus 15 is 0. Indeed, that's what you're supposed to have. Let's continue. Please watch this video as many times as you need, because after that, you're not going to understand. You have to practice on your own. And by the way, this is homework. I forgot. Yeah, I'm going to do some. I'm not going to do all of them. So this is -3 times 1 plus -3 times -8/3 minus 5 and 1, right? So this is -3. This is what? 8. And this is -5. So this is -8 and 8. That's 0. Now you compute that one more time for the last column, right? I'm showing you how to verify. This is not, you don't have to do this thing. So -3 times 0 plus -3 times -1/3. And then this is -5 times 0. So this is 0, this is 1, right? And this is 0. And you get 1. And in fact, that's what you need, right? That's what you need. So you got the identity. So A times A inverse equals the identity. So now you know how to compute, you know how to do the dot product, you know how to find an inverse. You also know how to, before you attempt to find an inverse, you know how to verify if the matrix has an inverse or not. So let me write this down. So you know, okay, facts. Let's call this I don't know how can I say this. Okay, let's see. So what you learned so far until now is that if the determinant is 0, implies, right, no inverse. Okay, what else? We said that to solve, or to find a inverse, you must use, or you can use Gaussian elimination, right? What else I need to do after that? Then to verify A inverse is correct or computational correct, use matrix multiplication. In other words, the dot product. And your result must be equal to the identity matrix, right? So this is why you need to remember these facts, right? So if the determinant equals 0, there is no inverse. If the determinant exists, it means that the determinant is not equal to 0, then you can find an inverse using Gaussian elimination. To verify a inverse is computational correct. In other words, to verify that you didn't make a mistake, you can use matrix multiplication. And to be more specific, you're using the dot product, and your result must be equal to the identity matrix, or in other words, A times A inverse times A should give you the identity, right? And that's what we did here. A times A inverse, right? A times A inverse equals the identity. Now I'm gonna ask you a question. What about if I swap the order? Should I get the same? What about if I multiply A inverse times A? Yeah, you should get the same, right? You should get the same. You should get the same. Is that always the case? No, that's not always the case. But in this case, it is true. Okay, let's see what else. That's it. That's how you do that. So basically, to find A inverse, you need to do Gaussian elimination, right? Before you do Gaussian elimination, you should check if the determinant exists. If it exists, then you do you find the inverse. If it doesn't, then you cannot use this method, right? Because that means if you want to solve the system of equations using the inverse method, then you need to verify first that A inverse exists. Okay, so let's do one more. Let's do the system of equations, and then after that we can prove that. Let's see. Let's do the number 5. Okay. Okay. So here I need to write, first I need to find the inverse. If I'm like, the goal is I have AX equals B. And you may say, what is that? This is AX equals B. And this is like, the notation I'm using is a little fancy though. So I mean, if this is the last time you see mathematics, at least you should remember this. This is from linear algebra. This is a course that you, when you finish calculus, you will take that course, right? Should not be like that. Based on Professor Strang from MIT, he always said that it should be backwards. You should take linear algebra and then calculus. But I don't know. I mean, that's what he said in an interview. So this is 635. Then you have what is the next thing? You have 1, 1, 1, 0, and then you have -4, 3, 4, and this is 21, this is 6, and this is 11. And for mathematicians, like the Professor Strang is like a Lamborghini, like a car. So that's the reason I'm mentioning him a lot of times, because he's really smart guy. If you have a chance, go to MIT courseware and watch his lectures. It's really interesting what he has in there. And they talk about this thing, AX equals B. The whole course is about AX equals B. Okay, so let's try to solve the system of equations. Oh, and I was explaining to you, I want to tell you what's AX equals B, my bad. So AX equals B means this. So this is the matrix A. I explained to you, I think already this in class. This is A, this is a matrix. And then you have the unknown vector. The unknown vector, we call them X hat, right? But in this case, it's X, Y, Z. And we abbreviate with that, the notation for that is just this vector is X, right? You can put another variable. The reason I'm using this variable is because that's the standard variable, and when you're taking this course, they always use this variable, right? And you have the other vector on the right side, the independent vector, and this is 21, this is 6, and this is 11. This is a hyperplane, by the way, and we're working in R3, 3 dimensions, right? Because that's the reason we have 3 variables, R3, right? Call this R3, right? Okay. So what you need to do is you need to, we have this AX equals B. Now that you understand what's the notation, or what, I mean, A stands for, X stands for, and B stands for, what we need to do is we need to we want to solve for X, right? And what we do is we take the inverse in both sides, and you get this A inverse times A, as I showed you already. That's the identity times X, and this is A inverse B. I times X, or the identity times X. You can think about, like, think simple, like the identity thing about is like a technically speaking, it's not correct what I'm going to say, but you can think about it's just a number. 1 times anything just give you the same thing, right? So this is this thing. So AX, sorry, not AX, X hat equals A inverse times B. Now, if I find A inverse and I multiply it times B, then that implies what? That I found my solutions, right, for the system of equations. So that's what I have to do next. So what I'm going to do next is I'm going to try to find the inverse of this matrix A, right? So let's try to find the inverse of that matrix A. So, okay. Okay, let's try to find the inverse of that. So you know what I have to do now, right? I have to augment it, and I have to put the identity on the right side. So that means this thing. I have to augment it. And what I need to do next is, oh my God, the little baby is making a noise. Okay, so what I need to do is, let's see. Okay, so we can do row swap, right? Because we usually want to have the ones on the first entry, or on the, I call it the main pivot, right? But it's not the main pivot. It's just that I like to have it in there, that position. So I'm gonna do a row swap. So this is row 2 with row 1. I swap those, and I want to exchange the position, right? So if I exchange the position here, copy, paste, I need to exchange the position. That means these two, they're gonna change, and I'm gonna have here 1 1 0 0 1 0, and then I have 6 3 5 1 0 0. Now I need to get rid of these guys, right? I told you again, it's the same process. Once you do this many times, and after that you become, you start visualizing things. Somebody say, "Oh, I wish I can visualize." No, everybody can visualize it. I'm not that bright. I tell you, I spend a lot of time doing this thing. That's the reason I can do it faster, or you might, whatever. Okay, so I need to get the zeros here. That's the goal, right? So how can I do that? So I need to multiply -6, row 1, plus row 2, and that will give me new row 2. And I can do the same for the third row, right? So I can do 4 row 1 plus row 3, give me new row 3. Okay, let's continue. Okay. So I'm gonna get rid of row 2 first. So that means that I need to multiply by -6 row 1, right? So -6 times 1 is -6 plus 6 is 0. -6 times 1 is -6 and 3 gives you -3. -6 times 0 is 0 and 5 gives you 5. -6 and 0 gives you 0 and 1 is 1. -6 and 1 is -6 and 0 it gives you -6. -6 and 0 is 0 and 0 is 0, right? So that's what we have so far, and that should be in green. I put it in brown. It should be in green because that's the green step, right? I don't want to confuse you. So this is the green step. Now what's next? What's next is I need to get rid of this guy, the last row. So that should be in brown. So 4 times 1 gives you 4 and 84 is 0. 4 and 1 is 4 and 3 is 7. 4 and 0 is 0 and 4 is 4. 4 and 0 is 0 and 0 is 0. 4 and 1 is 4 and 0 is 4. 4 and 0 is 0 and 1 is 1. Agree? You should say yes. Yes, I agree. Okay. Okay, what's next is, let's see what we can do after that. Let's see. Now this stage a little complicated, right? We need to think about it, right? That's sometimes these problems are crazy. So what you need to do is you need to multiply, we can multiply row 2 by 2. Row 2, row 2 plus row 3 give me new row 3. So let's do that. So what's changing? You ask yourself this question. The thing is changing is last row, right? That's what we claim. That's what we want. So 2 times 0 is 0, plus 0 is 0. 2 times -3 is -6, and 7 is 1. 2 and 5 is 10, and 4 is 14. 2 and 1 is 2, and 0 is 2. 2 and -6 is -12. -12 and 8 is -8, right? And then you have 2 and 0 is 0, and 1 is 1. Yes? Now you can do a row exchange one more time, right? So you can do, let's put that in another color. Row 2 and row 1. Row 2 and row 3, I'm sorry, they exchange, right? So if you compute that, let's change that, right? Because we're saying that we're going to change the order only. So this is 0, 1, 0, 1, 14, 2, -8, 1, 0, -3, 5, 1, -6, and 0, right? So what's next is you can just multiply, row 2 by 3. 3, row 2 plus row 3 give you new row 3. Yes? And I'm sorry, and this is just the way I do it. I'm not saying that this is the right way to do it. Like some professors might not like the way I do it. The only reason I'm doing longer sometimes is because I don't want to deal with the fraction. I told you, I'm just lazy. I don't want to deal with that. If I can avoid it, I will do that at all cost. So 3 times 0 is 0 plus 0 is 0. 3 times 3 is, I'm sorry, 3 times 1 is 3, minus 3 is 0. 3 times 14, it's 42. 42 and 5 is 47. 3 and 2 is 6, and 1 is 7. 3 and negative and 3 and -8 is -24, and -6 is -30. 3 and 1 is 3, and 0 is 3. Yes? So that's what we have so far. Yeah, I'm just checking really quick that, to avoid mistake. Let's see. Yeah, that's right. Now what we can do is, even though it's ugly, we have to divide by 47, right? There's no choice. No choice, right? So we have to divide by 47. So 1 over 47, 1 over 47, 1 over 47, row 3 gives you new row 3. So just divide by 47 everything, right? So let's erase that because that's gonna change. So 147 times 0 is 0, 147 times 0 is 0, 147 times 47 is just 1, 147 times 7 is 7 over 47. A negative 30 times 1 over 47 is negative 30 over 47. And then these things, right? Whatever that is. And 1 over 47 times 3 is 3 over 47. Yes? Now what's next? Next is we need to multiply row 3 by negative 14, right? That's what we need to do next. So negative 14, row 3 plus row 2, give me new row 2. So let's do that. Let's do that. So what's changing? What's changing is row 2. So let's multiply by negative 14, row 3, right? So negative 14 times 0 is 0 plus 0 is 0. Negative 14 times 0 is 0 and 1 is 1. Negative 14 and 1 is negative 14 and 14 gives you 0. Negative 14 times 7 over 47. So now you have to think a little bit. So 7 over 47, right? That's going to be a little ugly number, right? So this is negative 68 over 47. Can you simplify that? I don't know. Use your calculator at this point, right? Because you've had all those ugly fractions. So you cannot. So this is just whatever that is, negative 68 over 47. And then you compute this other number, right? Negative 30 times negative 14 times negative 30 over 47. So this is what negative, what is it? 42, 420, right? 12, yeah. Actually, it's positive, right? Yeah, it's positive. Positive 420 divided by 47. Can you simplify that? I don't know. You use your calculator. You get 420 over 47. So you cannot simplify that thing. What's next? Then we have negative 14 times 3 over 47. So this is negative 42 over 47. You know that. So this is negative 42 over 47. You cannot simplify that, right? 47, it's not divisible by 42. There's no way that that's divisible. Now what's next? Now what's next is you need to finish the identity, right? Or the Gaussian elimination. So what you need to do is you need to multiply negative row 2. I'm sorry, negative row 1. Negative row 2 plus row 1 give you new R1. So the last step will be negative row 2 plus row 1 will give you a new row 1. So let's do that. This turns out to be very tedious, this problem. So the only thing is changing is row 1. So multiply, right? Negative 2 times, remember you are in this stage, just in case. Let me put that step here so you don't get confused. So this is what I'm doing. Right? So negative 1 times 0 is 0 plus 1 is 1. Negative 1 times 1 is negative 1 and 1 is 0. Negative 1 and times 0 is 0 and 0 is 0. Negative 1 and negative 68 over 47 is just 68 over 47. Negative 1 times this number is just negative that number plus 1, right? So negative 420 over 47 plus 1, which is the same as saying 47 over 47. And if you compute that, you can use your calculator at this point because those numbers are turning ugly. So divided by 47, you should get negative 373 over 47. And then you compute the last one, right? The last one will be negative, well, 42 over 47 because negative 1 times negative 42 over 47 is just 42 over 47 plus 0 is just 42 over 47. Okay. So that's the identity. The inverse, I'm sorry. This is the inverse. Now, sorry about that. Now what's next? you need to multiply that by that vector b, and that will give you your solution, right? That will give you your solution x. Remember, x vector equals A inverse B. Okay, so this is the same. Let me change it just in case you're confused. Let me put that here, this one here, just in case you think, oh, what did he do? Okay. Now, what's next? I need to multiply this matrix A inverse. Now, before you do this, because these numbers are ugly, right? And you might feel like, oh my God, am I getting the right answer? And if I multiply this by the matrix A, this is going to be horrible because I have the fractions and all. I understand. I understand. So before you even try to do that, I'm going to show you how to do this in the calculator to make your life easier. Look, let me share this with you really fast. Give me 1 second. Let me share this with you, and then we go back to the Gaussian elimination. Oh, but before that, let me see what was the matrix. Okay, let me see if I can write this here better. So we were trying to calculate a 3 by 3, right? So this is 6, 3, 5, 1, 1, 0, and -4, 3, and 4. Okay, and we want to do the inverse, right? So second escape. So we do second is inverse. Let's see, what is that? Second this guy to the -1 inverse fractions. So let me check if I get the same thing. I hope I get the same thing. Not really. So I make some computational error, but it's not that bad. Well, let me show you what I mean. So let me go here, and now I can share this with you. So you can fix your mistakes when you make mistakes, because in the test, I will not give you anything annoying like this. So right now you can see my screen, I'm pretty sure. Let me see if you guys can see my screen. Give me 1 second. Yeah, you should be able to see my screen. Now, what you're gonna do is you're gonna press second, or let me clear this up first. Clear this up. Oh, okay. You press second anyway. Second matrix, or x to the -1. What happened? Second, x to the -1, and you create your matrix, right? Maybe you don't have one here. So let me erase these ones. Let me see if I can erase this thing. Clear, can I clear this up? Let me see. Not really. So let me go back to this, and we need to find an inverse of a 3 by 3, right? So you go where it says edit, and you press enter here, and you put 3 by 3, right? So now what the numbers were of that matrix, right? You have to remember what those numbers were. So the numbers for that matrix, let me see, matrix. Okay, those numbers, they were 6, 3, 3, 5, then 1, then 1. By the way, you have to watch this video until it completes, because tomorrow maybe I'm not gonna be able to be in school. So that's the reason I'm doing this long video, so you guys can practice, and you need to complete the assignment that I'm gonna give you tonight. 3 and 4. Okay, so once you enter that, you press second, and you quit, and then you go second matrix, and you go to now you have a 3 by 3, right? So you go second, not second, I'm sorry. Second, quit, and you do second again, math, not second matrix, and you click on the A matrix, and this is what you're supposed to have there. So inverse, it means you press this and you put to the -1. Now you're gonna get some ugly decimals, right? Because we get fractions. So what you need to do is you put second math. What is it here? Oh, it's just math. I'm sorry. So let's go back to that. Okay, so you have this ugly number, you put math, and you press where it says fractions. Press enter, and you get that. That's the inverse. Okay, so you don't need to do this by hand. That's what I'm trying to say. Don't do this by hand. If it's too annoying like this, right? Don't do this by hand. If I give you the homework and I want you to find inverse, you just do, like I said last time, you just do 2. And then if it's a 2 by 2, you can do by hand, right? But if it's a 3 by 3, just do 2 of them, and then the rest you can do with a calculator, like I'm showing you here. So let's review again one more time. So second matrix. If I want to exchange something, or if it's not a 3 by 3, I can change that here, right? So I enter my values. Once I enter my values, then I press second, quit, then I go second matrix. I press A, you will get this, and then you go to the -1, right? Because that's the inverse. And you get those ugly numbers. So you press math, and you press fraction, and you get the answer as nice as you want, right? So that's the inverse here, right? So that's the inverse. Let me see if I have the same in my calculator right now, just to verify. So if you messed up in the process, or the computer wrong for some reason, you can exchange it and you just put this thing, right? I mean, I know you know how to do it. It's just that you messed up something, right? Okay. And on the test, like I said, I will not give you anything crazy. I will make sure that the numbers are nice for you. So now that's how you do it, right? So let's go back to the slides. And let's see. Okay, so this is what we have so far. Why are you guys gonna do? What happened? Okay. Okay. So now we have the inverse, right? So whatever that was, if I made a mistake, you can fix it, try to see what I did wrong. But anyway, I'm giving you the right answers because I use a calculator. So this is 4/47, 3/47. Especially when you have fractions like this, just check always with your calculator if you compute it wrong or not wrong. You know, it's good habit to check. So this is 44/47 because it's very easy to make mistake in this thing. 5/47, 7/47. -30/47. I'm not interested in you computing these annoying matrices. I'm interested in if to make sure that you understand these concepts. 3/47. So this is A inverse, right? Now you need to multiply by B. And B, let's see what's B. See, I made mistake. Let's see what I made mistake. I made mistake in the second row, right? And in the first row. Not everything is wrong. The fractions, the denominators are correct. I just made some silly mistakes somewhere, and then everything turns out to be bad. But anyway, you can compute this A inverse with the calculator, right? You don't need to do by hand if it's like ugly like this. Okay, let's see. And now we have our vector is what? 21, 6, and 11. 21, 6, and 11. So this gives you X, right? So let's see. We have to use the dot product. So this is 4/47 times 21 plus 3/47 times 6 plus -45/47 times 11. Just make sure that you understand the concept. So this is 484/47. Can you simplify that? I don't think so. 84/47. Let's see. Oh, wait. That stays like that. 18/47. -55/47. Just compute these things, right? So this is 94, 102, 102 and minus 55. And you get 47/47, which is 1. So we have our first vector, right? So vector, this guy is 1. Next, we need to compute the second row, right? So negative 47 times 21 plus 44 over 47 times 6 plus 5 over 47 times 6. So this is negative 84 over 47. This is, what is it, 264, right? Yeah, 264 over 47. And then this is 30 over 47, right? So this is the same as negative 54 plus, yeah, negative 54 and this number, so that would be 210 over 47. Let's check. Yeah, so we said that it was negative 54, 210 divided by 47, I think that's going to simplify. Let's see what's wrong. This cannot be wrong because this is a calculator. So negative 44 over 47 times 21, 44. Is that 44? What is that inverse? Let me see that maybe I copied wrong that thing. No, that's right. It's 44 over 47. Okay, let's double check. So this is negative 4 over 47 times 21 plus 44 over 47 times 6 plus 5 over 47 times 6. So this is negative 84. This is 264 and this is 30. No, let's check. What's wrong? So this is 294 minus 84 is 210 divided by 47. And it turns out to be 210. Okay, let's put that for now. Let me double check if if vector B is 21, 6, and 11. 21, 6, yeah, that's right. What's supposed to be the answer? Hey, it's supposed to be 5. Well, okay, we'll check that one in a little bit. Let's see what's wrong with that thing after that. Okay, maybe I miss a sign or something. Let me double check if I miss a sign. Maybe I miss a sign, and that will make a big problem. It seems okay now. I will calculate it again, this thing. And then we have the last one, right? So 7 over 47 times 21 plus negative 30 over 47 times 20 times 6. And then this is 3 over 47 times 11. Let's check. So this is 147 over 47. This is negative 180 over 47. And this one is 33 over 47. So this is what, 3? This is 33, right? 33, negative 33, and 33, that's 0. So let's see if that was 0. I think that was 0. Yes, that's right. So that means the mistakes is on row 2. Why is mistake on row 2? Let's check. And I have my matrix exactly the same as they have? Yes, I do. Same thing. Okay, let's check. Negative 1. I think I checked. I don't know what's wrong. So 47, 21 plus 44 over 47 times 6 plus 5 over 47. I know what I did wrong. Okay, this is negative 84 over 47. And this is 264 over 47. And this is 55 over 47. That's the reason. Okay, so this is what, 180, and this is 233, I guess. Let's double check. 64 minus 84, 180 plus 55 divided by 47. Yeah, exactly. 235 over 47, and this is equal to 5. Yes. So as you can see, it does work, right? The only part that you need to be careful is when you're doing the matrix multiplication, right? One mistake, everything is wrong, right? So this is another way to use system of equations using the inverse instead of Gaussian. I mean, well, you use Gaussian elimination partially, right? But that's not the only way to do it. It means instead of finding the inverse that we're using Gaussian elimination, which is very easy to make mistake, we can use join matrix, right? I will show you that next time. Okay, so I hope you understand how to find the solution vector, right, for the system of equations. If you're still confused, I strongly suggest you to rewatch this as many times. Not everything, because I know this is almost like 1 hour and 30 minutes, but like the parts that you don't get it, right? Like, for example, like in this thing that I got confused the first time, try to see where I made a mistake between here and downward, right? Try to see where, or you can start from by yourself and try to figure it out, or use a calculator and just try to apply the concept, right? Now that you know how to find the A inverse, right? You do A inverse times B, and then you get your answer, right? You can use the calculator. So basically, if you have this situation, this equation, right? You can just find the inverse in the calculator, you multiply times vector B, and you're done. That would be very effective. Actually, that would be better than using system of equations, as long as the inverse exists, right? You can use a calculator, put A inverse of your original matrix, find A inverse, and you multiply with calculator also, or you can put multiply by hand, because that product is not big deal, right? It's easier than the Gaussian elimination. Okay, I hope that makes sense. I hope you like it, and if you don't like it, well, at least I was trying to make it fun as much as I could. Have a good night.